This week's topic is the origins of the universe. The universe is made up of all of the matter and energy in existence, and all of the empty space in between. We don't know if the universe goes on forever or if it has an end. So we're going to try to answer this with two parts. The first is the story of the universe, and the second is the evidence for the theory. The story of the universe basically begins that first there was nothing. All of the matter and energy in the entire universe is condensed into a single point called a singularity. Then the singularity explodes. The Big Bang Theory states that about 13.7 billion years ago, all of the matter in the universe was condensed into one tiny point called a singularity. Then, something or someone caused the singularity to explode, creating all of the matter in the universe, and the universe is still expanding today. In order to understand the evidence for this theory, we need to know a little bit about what astronomers do. As we've studied before, the electromagnetic spectrum is a list of all of the waves in order from shortest to longest. And I'd like to call attention to the fact that in the visible light spectrum, blue and violet are on the short side, and orange and red are on the long side. This scientist, Gustav Kirchhoff, discovered that every element has a unique light fingerprint called a spectrograph. And an example of this would be on the top here. You can see this pattern of colored lines is the spectrograph for hydrogen, and it's very different from this other spectrograph on the bottom, which is the spectrograph for iron. On Earth, when we view hydrogen, its spectrograph looks like this pattern of lines. However, when it's viewed through a telescope, all of its lines are shifted over to the red side or long wave side of the spectrum. The reason for this is called the Doppler effect, and it states that when an object in space is moving toward us, its spectrograph appears bluer than it really is. When an object in space is moving away from us, its spectrograph appears redder than it really is. And it turns out that all of the other galaxies we can observe are redshifting, which means that they are moving away from us. If all these galaxies are moving away from us, this means that the universe must be expanding. And if the universe is expanding, it must have been smaller a long time ago. And this is really the basic idea for the Big Bang Theory. The redshift is not the only piece of evidence for the Big Bang Theory, however. The second piece of evidence is what we call the cosmic background radiation, which is the heat left over from the Big Bang, and it was discovered in space, and you can see this photograph is actually a picture of that heat. So how did the Big Bang lead to us? Well, in order to understand that, we need to know a little bit about gravity. Gravity is another one of those fundamental forces, and basically it states that anything that has mass is attracted to anything else that has mass. So in space, tiny bits of dust and rock that were floating in space after the Big Bang would collide, melt, and stick together in the same way that a snowball gets bigger and bigger as you pack it together. They grow and grow in size each time they collide, and this is how all of the celestial objects might have formed. So as these celestial objects formed, the biggest ones became stars, smaller ones became planets, moons, asteroids, meteors, and comets, or just clouds of dust called nebula. Now, there's a big difference between stars and all of the other celestial objects. In order to understand that, we're going to listen to this song by They Might Be Giants.
The sun is a mass of incandescent gas.
Incandescent means something that gives off light and heat.
A gigantic nuclear furnace where hydrogen is built into helium at a temperature of millions of degrees.
One of the lines in the song states that hydrogen is built into helium. The scientific term for this is fusion. It's the process of joining two simple atoms into a more complex atom. Fusion releases a ton of energy. You can see in this diagram we have two circles with H's in the middle. Those represent two hydrogen atoms. Now normally they are kept apart by an extremely powerful force called the strong nuclear force. Only in a star, because a star is so massive, its gravity can actually squish those hydrogen atoms together so much that it actually pops the strong nuclear force, and that's what releases that enormous amount of energy, and that's why stars shine.
The sun is large, the sun is
the song, it states that the Sun is only a medium-sized star. Compared to other stars, the Sun is a middle-aged, medium-sized, medium-temperature, and medium-brightness star. Luminosity is a vocabulary word, and it refers to how bright a star actually is. This is not necessarily the same as how bright it looks to us in the sky. In this diagram, we see what we call the life cycle of a star. Stars begin as a stellar nebula, which is a cloud of dust and gas in space, and through the power of gravity, those little bits of dust start to stick together and form into a bigger and bigger object. If that object becomes so big that it actually starts to undergo fusion, like we talked about, it can become a star, and that's what we call a main sequence star. As the main sequence star starts to run out of that hydrogen fuel, it starts to burn heavier and heavier elements like helium, iron, carbon, and if those heavier elements become less stable fuel, which makes the star turn into a red giant, which is a very unstable large star. And when it becomes unstable, it can eventually explode into what we call either a planetary nebula explosion or a supernova. After that explosion, the star starts to collapse back in on itself, and it can become a very old star called a white dwarf, which is a very hot, very dim star. Or, if the circumstances are just right, it could turn into what we call a neutron star or a black hole. You don't need to know too much about neutron stars or black holes. We'll talk about it in class, but I won't put that into this video. On page 15 of your reference table, we have this diagram which shows how we describe stars. You'll notice that as it goes from left to right, the color of the star changes from blue to white to yellow to orange to red, and as the color changes, the temperature gets colder and colder. As you go from bottom to top of this chart, you see that that refers to the star's luminosity, which again is its brightness, how much light it's giving off, as well as how big the star is, from small all the way to massive. So these stars in that middle diagonal part are called the main sequence stars. The ones that are on the lower bottom left corner are called the white dwarf stars, and the ones in the upper right corner are called the giants and the supergiant stars. The last thing we need to know about this topic is that when you have 100 billion stars all in one area, we call that a galaxy. The Milky Way is called a spiral-shaped galaxy, and you can see a picture of it here. And you need to know that we are not in the center of our galaxy. We are actually in one of these spiral arms.